morning, everybody. Good afternoon, if you are a little bit in different time zone. And thanks, Murad, for the introduction and inviting me to talk to you about the work that we have been doing. So today, my plan is to talk about what we have been doing in Johns Hopkins this summer, which was a multilingual and code switching for speech recognition. So the plan for the talk is to be interactive. I have a content that could last for over 3 hours. So I will try to go fast. If you feel you want to stop me, feel free to do so. But before, you guys still can hear me, right? No?
Yes, we can hear you.
All right, good. All right. So before I start to the introduction, I'd just like to make a quick announcement. So SLT, which is Spoken Language Technology Workshop, is happening for the first time in the Middle East. In fact, this is the first speech conference to happen in the Middle East, and this happening in Doha, 9th to 11th of January. So I'd like to invite you guys to consider joining in person. It's going to be a great event. Beside the great workshop and technical program, we also have a hackathon happening 2 days before, where it's a great opportunity for early career and researchers and those who haven't had a chance to work in speech recognition to come, and over 2 days, you will build some technology. We have built a great program on 8th and 9th of January 2023. Although we call it SLT 2022, but it's happening in 2023, and this time is not because of the pandemic, similar to previous events, but this is because of the World Cup that you may know is happening here in Qatar. So let me know if you are interested to join or you have a problem. Just go to SLT and try to be here in person. That would be a great opportunity, especially if you are in the region. All right, okay. So let me start. Murad, you said I could have 40-45 minutes of discussion, and then I'll give 10-15 minutes question and answer. I'll try to plan to stay with it. Right, okay. So first of all, today the discussion will be about multilingual and code switching in speech recognition. And I would like to start by showing more about the team. So this happened in Baltimore this summer, but before the work happened in Baltimore, we spent we had a couple of meetings, one in Doha and one in Edinburgh, to prepare the team to get the work to be done. So that's not my work, that's a team, it's the work of a large group of people, colleagues from Edinburgh, from New York University, from the US, from the UK, from multiple places. And this is how you can see it's a multilingual effort, which require a multilingual team as well. So we have people from all over the place, as you can see on the map here. So we had QCRI, Johns Hopkins, University of Edinburgh, New York University, IIT Bombay, CMU Pittsburgh, CMU Qatar. We have a colleague, of course, from Johns Hopkins, and we had a support from different companies from Canary, Unifor, and Microsoft. So with some acknowledgement, but let's go into the challenge of code switching. So the talk will I'll try to highlight on 5 aspects. Why do we need to worry about code switching in speech recognition? I'm speaking English. Perhaps Murad will be speaking French, and our colleague in France, in Germany, will be speaking German. Why do we switch between languages? And then we'll say, when code switching is happening, it's not just a problem of computer science. There is a linguistic aspect that makes the code switching happen. And then, today to build a great system and all the deep learning and interesting and transformers and all these nice architectures benefit from lots of hyperparameter, lots of data. You have to have a real data to generate to build a good system. But this data, where do we get the data from? We have often a lot of data with switch between different languages, so we look at code switching data. And then now we need to build a model for the code switching, And after building the model, definitely we have to evaluate to know if we are doing good job or a bad job. And then the summary and the feature. I mean, some of these things may be intuitive, evaluation. What's special about evaluation? Word error is great, If I said good morning and you said bad morning, it's 50% word error. It's simple, right? Does it make any difference to code switching or multilingual? We talk about. Right. So introduction to code switching. So code switching happens when so code switching happens when the speaker makes more than one language in a single sentence. This is the definition of code switching. And what we are meaning by code switching is ideally something beyond borrowing the word. So if I say blah, 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 blah in Arabic, Google, blah, 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 this is not what we meant by code switching. We mean when people are switching really between multiple languages. For example, Arabic and English is quite common, and to the extent where people started to give it a new name, Arabic. Hindi English, people do this all the time, and they call it English. Again, I'm using an example, not just to be focused on the English or the Arabizi or the Singaporean English, we call it English or whatever. No, but let's use it as an example. And normally it happens in a casual text of social media, but not often, right? Just because, for example, Arabic, you may like code switching happening in informal speech where people talk about business. They have to go to English. For example, when I'm asked to give a talk in Arabic, unfortunately, I have to describe acoustic modeling or hidden market model. I don't know how to say it in Arabic. I have to refer to English. And code switching is genuine from a communication point of view. And this is really important. It's genuine. Not people are trying to make up, not people are trying to insert a word or two. It's not common, but it is important. And the best example to use here is when Trump mom was in the hospital and her, she was sick but she was very, very sick. She forgot English, right? She has to go back to her mother language. So there are cases where, you are in a hospital and you have someone who's sick, right? You have to deal with this person, you have to understand. And you see this quite common in cases like immigration or a country which has a lot of laborers coming from abroad. The cases where you travel and you have to deal with borders or hospitals. So on Earth we have about 7,000 languages. So if you look at a multilingual, why you need to handle more than one language? So think of like something like the World Cup is happening here. All sorts of nationalities coming to cheer and enjoy the event. How do they communicate with the machine, right? The machine is able to understand Arabic and English. Right? If we press 1 and 2 and 7,552, I mean, it's not quite practical. And the question would be, how many languages an ASR can recognize? I think recently we heard about different models and different multilingual systems coming where it can handle more than one language. But if you could see people are bragging, have you heard about this new open source? It has 20 languages. Okay, good, it handles 20 languages. How about the African continent? How about people in the Far East? How about places where countries are small, but it's a couple of millions? How do we deal with this language? And multi-dialect can be more challenging than multilingual because language similarity. For example, if you look at the Arabic region, you have 22 dialects. India, for example, is known as the continent of multilingual. The machine is able to recognize multilingual, but there are cases where bilingual families or multinational societies. So this is an example just to put the problem in front of you, where you can see there's a 15 wave in the Arabic world where we can say Happy New Year. This is, I'm not making this up. In Algeria, we'd say it's different than Mauritania, it's different than Egypt, maybe slightly similar to Libya. If you go to the Gulf region, you will see how you say it. And of course, when you speak about India, it's very interesting. It's a land of languages. So these are 30 languages in India. This is 15 languages in Arabic when we say Happy New Year. Right. So, so here is how we look at the problem, right? So So in a code switching, there are three things happening in the code switching. There is an environment around the code switching to make it happen. You know, you want to understand the environment to model it, right? Because unless you understand why code switching is happening, you wouldn't be able to solve it. I mean, it's okay to build a model with a lexicon, which is lexicon in speech recognition. It is the finite number of words that the ASR is recognizing, right? What we expect. Oh, now we're going to add Google. Now we're going to add, oh, there's a new company called Snapchat. We add Snapchat. Oh, there's a new company called Twitter. We add Twitter. But then, you know, the lexicon will keep going forever. You have to understand why code switching is happening and how you handle it. So this is the environment. And the environment where people make speech where we have to model them, and then eventually we'll generate text. So this is an example of the text where I'd like to here show very interesting. So maybe when I code switch between Arabic and English, I'll say النهارده my talk is about, right? So this is genuine code switching thing, and if a bilingual speaker here can confirm if he or she would have said this. Do you guys like النهارده my talk is about? No? Yes? Maybe? Okay, good. So let us assume that this is valid. But let us now go and translate it. So today my talk morning about. So when you translate the Arabic to English, the English doesn't sound right. Grammatically is wrong, right? So when we do code switching, we don't mind the language anymore, right? You know, now I'm making my own grammar. So if I try to understand, if I try to model the code switching text, we have to really understand what is happening. So the linguistic theory, the grammar for the English is the last line. Today, my morning talk about. I mean, of course, is about, right? But when I decided as a bilingual speaker, in some of the cases to insert English words in Arabic, I started to break the grammar. So for the environment, we try to understand why code switching happens and how to characterize code switching. And is in a way to make a code switching. It is the number of L2, the second language words in the L1. What actually motivates me to what motivates us to do code switching? Is it a lexical cues or acoustic? Sorry, how do we detect the code switching? From what? From the lexical cues, from the words, or from the voice, from how we speak? And one thing we would like to look at is the social cues. Is it because when I'm with my friends, such as having a friendly discussion after the match, or when I'm in a business meeting where I have to speak about speech and I have to use technical terms? And can we generalize all our findings across languages? So if I understood, if we figure out something happening in English, Hindu, in English Telugu, can we apply it on French Algerian or Egyptian English or no? This is about the environment. And then when we come to the speech, we look at things like how to recognize code switching. And how to recognize code switching, there are multiple things to look at. We need data, right, to build the model. And the data, how do we build the data? We need to have a semi-supervised technique to collect data, or we do self-supervised, or we do data augmentation. There's no or, of course. We try to address which one of them is more practical. And then, you know, this is on the speech in the model for the text. We use the code switching text data, or we use the code switching audio to generate data and modeling, and of course, building efficient data. After all of this, we need to build a tool to evaluate code switching, and I'll talk later about why tool is important. And how to evaluate and understand the code switching, the human acceptability for code switching and orthography and semantics. That's from the text point of view. So this is a work for trying to characterize and predict code switching. So this is a work done by our colleagues in Edinburgh. They have the four of them with Professor Peter have been focusing on understanding code switching. So code switching is very reliable phenomenon, right? So here is, you look at different examples. Look at the English, the Gaelic English example at the top, followed by the Hindi after that, and then the Zola in South Africa. I'll give you a couple of seconds to look at it. So what you see here is the frequency of code switching, right? So in the Scottish Gaelic English, it doesn't happen as often as in Hindi English, right? But if you try to look at South African one, you could find in one sentence more than 5 languages, and I was blown away every time. First time I heard this. But it means if you are building a system for South African at any moment in time, it should be able to expect 5 languages. And this is not 5 borrowed words, it's 5 languages happening at the same time. So if we train a system that's able to deal with the code switch on a data set, will our experience will be able to predict with the code switching behavior in another language? I want you to think about it, because when we build an ASR, or we learn how the English people speak, and then we build a system that tries to understand English. It's a lexicon. We get a couple of 100 hours. We have 30,000 words. The 30,000 words will give us 5% out of vocabulary. We build this from our experience. We take it to German. It gives us a decent results. Now, can I learn something from the Scottish Gaelic English code switching and take it to South Africa? This is what we are trying to do to predict with the code switching behavior. And here we try to understand the feature, the segment duration, the rate for the code switching, and why higher level of variables affect the code switching behavior. So, for example, if we look at the metrics where you evaluate the code switching, are they reliable? Can they use in isolation? What happens if we combine these metrics into fully code switching behavior? So there have been a few cases, for example, a few indices. So we have a code switching indicator where we count the number of words. But I mean, there are different evaluation metrics, such as an M-index, where based on the previous word, there's a number of changes happening. Can we take something? So, for example, there's the M-index and I-index, different ways to measure. And burstness. So, for example, I have the speech happening, and what is the likelihood that at any moment in time we'll see a different language happening? Again, if you apply something on Scottish English, you cannot really generalize it on Zolo. So you can have a negative memory. You can have a memory where you try to predict. So we try to do this on a different languages, as you see here: Sini, Chinese English, Sobi. Very rich full of languages. This is the Telugu Bangalore. We tried to some audiobooks, and we did a little bit of Arabic, and we look at four ways to evaluate to measure the amount of code switching happening. So here's an example where you see all the matrices across different languages, such as the M-index or the memory, in the handwriting text, in different text, where you see in a technical discussion versus friendly phone call, how the evaluation metrics could differ. And here you can see an example, for example, what we can generalize on Chinese, the Sini corpus, I think it was a phone call, cannot be easily generalized on another language. So here is a lot of work has been done, and then hopefully sometime by the end of next month we'll have the complete report. You can go ahead and read this. So I just want to share with you what we have been doing into this. The other topic that I'd like to talk about is predicting code switching, right? So will people have a code switching whether the formality in the speech or in a friendly discussion? So, for example, you just try to see what could trigger code switching. So what's role? So there are tons of things we can look at, but we have a good intuition that formality could be one of the things that's leading to code switching, or could be the cue for for a code switching. So formality is a universal, a language independent. I mean, you know, because again, think about it. When we try to understand code switching, we are not looking at Arabic English. We are not looking at South African. We are not looking at Gaelic English. We are looking at something hopefully universal, right? So formality is one of the universal measures, and then you can apply it. Will the domain and conversation have inherent formality? I mean, we assume, because when you have an anchor speaker in the news, you would expect the anchor speaker to be more formal than when we chat over the phone. And of course, formality indirectly go on speech setting and speaker relationship. So one of the ways that we have looked at is how to measure formality. And this is, again, this is very limited work has been done in the speech, but some interesting work has been done in the NLP, and we adapt this. So of course, we take the speech, we transcribe it, or manually or verbatimly, and we use the F score, and here is the F measure for accuracy, but formality measure, which is dependent on the noun, the adjective, preposition, article, pronoun, verb, adverb, and then interrogation. So variation in fundamental frequency, the pitch, acoustic signal, the speaking rate, the breathing, the non-lexical feature, the laughter. You know, started to look at these kind of features as because this could be potential features as well for changing the formality and variation in fundamental frequency, the articulation of the rate. Hopefully, when we now try to speak to you formal, I've been trying to keep my fundamental frequency, which is not changing the pitch quickly, not going louder, softer, quieter, not laughing, trying to maintain the speed rate, the speaking rate. All these kind of things could potentially indicate that my formality of the speech is trying to be. We look at CME corpus, we look at Miami corpus, which is Spanish English. We try to apply this on the Gaelic English as well. And the experiment have been done on the text. And here we could see. So the conversational part, you can see. So if you go left, means more formal. If you go right, it's more formal. The left is this formal. So formality score lower to higher. So lower is the left, higher to right. So this is across 3 different corpus: the English and post-English. When I say English, it's not just English, Gaelic, Spanish, English, right? And does it look very bad? Looks interesting. We see telephony is very informal. Makes sense, because when I speak over the phone, most likely I will not be having an interview. But when I go to the Supreme Court at the end, there's a good chance that the discussion will be very, very formal, right? And what's interesting is that this is potentially valid across different corpus, across different languages. And here you can see. And then one thing we looked at, okay, you know what? Because when you measure these parameters in the NLP, you have to go to one language. So the mono Spanish, you take it to mono English, you translate it, you back translate it to mono Spanish, and you give us the same formality measure. So it looks like it's robust from this. So this is an example of predicting the formality on the code switching. Again, there are a lot of work to be done. A lot of discussion can be talked about it, but I would like to go about it. Now, now we want to build a code switching system, ASR, right? To do this, the ASR, the automatic speech recognition, is mainly based on 2 famous architectures. Actually, they are converging back again. So at some point in the past, we used it to call it the vanilla system, or the standard. It's not the standard anymore. The HMM system, which is a combination of multiple systems. We have we modeled the speech, which is hidden market model at that point, or deep neural network. But again, it's a hybrid system, right? We modeled the acoustics, and the acoustics is how I say things, right? when I say ba in Egypt, we never say pa, right? We don't have this phoneme, right? We don't have va in Arabic, but at the same time, English doesn't have ha, doesn't have a, right? This is the acoustic, the phoneme unit or the grapheme unit, it depends. And the other one is language model, which is what you should expect next. And I assume that everybody knows about the language model. And the third one is the lexicon, the number of words that we expect. And more recently, we try to build the end-to-end where we put everything together and we have the system is trying to be able to understand. So both systems assume that we have in-domain data that we could use to train model. Unfortunately, in code switching, as I said at the beginning, we don't have a lot of data to help us to train such a system. So we need to synthesize data. So building an accurate language model, we need to get lots and lots of text. We don't have such text. And then the question is, how can we generate text? Starting by the simple example. Can we use linguistic theory to guide us to generate? Yeah, of course, linguistic theory is simple. Verb, noun, adjective, whatever structure the language is saying, but this is from the language point of view. Remember, I'm not speaking English, I'm not speaking Arabic, I'm mixing the two together and making my own new language, right? So can we use a language theory? Can we use parallel text? There's a little bit of a code switching. So can we use some, imagine I have the BBC English and I have Al Jazeera Arabic as the two sources of information. I have a little bit of a phone call in code switching. Can I use this a little bit of a phone call code switching to give me an intuition or to infer how can we mix the two languages together? Alternatively, what we have seen recently from pre-trained language model, which has been so great. So if I have a BERT model very good in Arabic and BERT model has been very good in English, can I use it to generate text for the two of them, or even more recently, a multilingual pre-trained model, or merge. So this is the work that has been done by colleagues from different labs. Amir and Inji have been looking at the linguistic. Bara has been looking at using pre-trained. Jay and Brian has been looking at generation using pairwise methods and other stuff where we could, have the two language pairs and some pre-trained. So here we propose using an ASR for building this model where we could potentially look at taking the benefit from ASR, MT, NLP. Here is an example of how we can do that. So if you look at this example, على الصحفيين أن يتعلموا كيف يفاوضون بجماعة. Right? We try to build a text from this one. This is only Arabic that we have. So what we could use is just use this sentence as it is and use some engine, either QCRI's machine translation. They have a really good dialectal translator we could use for this, or something else, maybe Google or public. We apply some NLP pipeline where we can have the prefix, the stem, the suffix for each word, and then use some linguistic tool to identify which part of the sentence can we translate, where is the switch point. We use code switching generation, and we align the output together. And then we end up على الصحفيين أن يتعلموا كيف negotiate with the matter, or على الجورناليست أن يتعلموا كيف يفاوضون بالجماعة, or على الجورناليست أن يتعلموا كيف يفاوضون with humanity. Do you guys like the output from here? Just want to make sure that anyone here is still listening to me. Anyone?
Go ahead, Ahmed.
All right, good. Okay. So here is we have taken this sentence and we managed to generate 3 outputs in there, right? And then we could see from different ways of doing the alignment, using the Farasa, using embed, using equivalence constraint theory. And equivalence constraint theory is a very interesting because that's a theory from a linguist where they say, you know what, how people will be doing code switching and how the output from code switching is happening, which is great. You know, we did this on a multiple corpus. We applied this on a SCOA data, which is, you know, United Nations speech for a couple of days. And then we generated lots and lots of lovely text. And, you know, we asked people, guys, what do you think about the output? Do you like our output or no, right? And we apply some mean opinion score where, you know, 1 is very bad output, 5 is perfect output. And then we look at the generated output from different people. And then I just want to show yes, the subjective evaluation. So the generated text with code switching, if you look here, so the real code switching has 60%, right? And the generated code switching has 80% acceptance. And then the random replacement somewhere in the text, you know, we managed to replace in Arabic with English, get 20%. So we were all over the moon, right? Just like, you know what, we can build a machine that generates code switching text that people like more than real data. How do you guys think of it? Is it something good or bad? Need an opinion. Is it good? You put your hand up if you think it's good. I don't see anything. I don't know if even people can interact with it. So anyway, here at this stage, we found that our automatically generated code switching text is preferred by human than real, right? So which is amazing, right? So you know what, linguistic rule, you know, helped us a lot. But now the question is, we generated an amazing text. Will this amazing text help the ASR? And the answer was a little bit disappointing. So we found that the generated text helped us a little bit in the language model, helped us a little bit in the ASR. When we use the baseline, and this is our objective evaluation, not objective. Now, you know what, because who cares if the human like it or not? Basically, at the end of the day, I'd like to build a system that's able to recognize me when I switch between Arabic and English. And we found that the automatically generated text that's loved by human did give us a little bit of a gain. And then the next question is, what would be the objective evaluation when we do random replacement? You know, it doesn't matter really. We don't really care about the linguistic rules. We just, you know, we didn't do crazy. We still did a good job in alignment. We did a good job in interpretation and morphological output interpretation. We did all the sensible things, but the point where we do code switching, we did not follow the linguistic rule. And here's the surprise: random replacement happened to be better, and this came out of an interesting surprise. We validated initially, we thought it's a bug, but we validated this on a multiple scenario, on a multiple corpus, and this is again back to my initial point. When we do code switching, we don't mind the language rule. We make our own language here. And then we get a marginal improvement up to 6% relative reduction in complexity and in word overlay. And you see here with the random replacement, we have a 35% relative reduction in complexity and 2.7% in word overlay. So this is a random replacement. So the takeaway out of this is morphological segmentation is crucial, of course. We need to have a reliable machine translation, of course. But improving the quality of the code switching does not really mean improve the quality of the ASR. And random replacement happen to be better than this. There are multiple ways we have done a lot of this with the code switching. Given that I have about 10 minutes in my talk, I would like to go to the last part for the evaluation of the code switching. Now you understand that we need to do something interesting with the modeling, and we identify the problem. And now we have managed to build an ASR that's able to deal with this. And we have another interesting problem at this stage, which is we have some interesting output. Which is evaluating the code switching ASR. I have about 15 minutes. All right. So evaluating the code switching ASR. Why evaluating the code switching ASR matter? Because this is the output from the ASR. And if you look at this, and weekend, my friends, weekend, mainly family, we visit the two family, and we also have to do some exercise, right? So what kind of phenomena you see here that you don't normally see in a monolingual ASR? I'll give you a couple of seconds to look at it. And feel free to write if you see something interesting happening. So the first thing is this: is the weekend Arabic word or English word? I'm certain that because we say a lot of weekend now in Arabic, especially in dialectal Arabic. Remember, code switching is not happening between a formal speech and English. Most of the time it's happening as a dialectal speech. And guess what? The ASR did not transcribe fruitful as a one word. It's fruit and full. And full is some kind of flower in Arabic. So the ASR, is the ASR bad here? No. It gives me what I said, but it didn't give me the intuition of what I said. I said fruitful, right? So there's a standard orthography. There's a cross transcription, and there is a mixed transcription. So when you put all of these things together and you measure character error rate, it's 50%, and word error rate is 87%. This is a horrible system, right? Because in what a system is giving you 80% word error rate. But when we ask human, we give the text to humans, and this output of the ASR, tell us if you like it or not. And just you say, we ask the human to do the minimum edits based on the ASR output. We realize that the character error rate actually is not 50%, it's 20%. And the word error is not 80%, it's under 50%. So there's a huge problem in evaluating code switching. And of course, if I cannot measure the quality of the system, how on earth can I improve it, right? Because normally people every say, hey, I have the best paper award, or I have the best system because I managed to reduce the word rate from 20% to 19.5% or to 19%. That's substantial gain, right? But until you are able to measure the quality of the system, you cannot measure the improvement. So the goal here is to assess different ASR evaluation metrics by correlating them against human, because the only thing we can trust at this stage of human, and here we're back to our subjective evaluation, because this is the output from the ASR. How to quantify human judgment? So we design more of a fine-grained human annotation task, and we'll ask the human to look at across different systems and build human acceptability for them. For a system, we need to make sure if the human accepts the output of this system or not. And then we have the evaluation metric, where we cover commonly used matrices, adding the three approaches that are behind the system, and we correlate with the human. So the guidelines was that we have 4 bilingual speakers, we give them the output of different ASR systems, and we ask them to like it and make the minimum like it or don't like it. And if you don't like it, make the minimum edit changes. It doesn't have to be your standard, because we don't know really what's the definition of standard into the output. So here is the examples: engineering, examine, financial art. The rule of transcription, the only thing we give is that single word cannot have Arabic and English. This is the way we are doing this in Telugu as well, to like our findings. So anything else, if the word financial is written in Arabic, financial written in English, it doesn't matter, but has to be written in single. And then we apply the minimum edit distance, and we find, the inter-annotation between the people is reasonable, between the character error rate and the word error rate. So there is a pattern. And the ground truth is what the human will do. So we look at different metrics, matching error rate and word information loss. And of course, we looked at transliteration. So transliteration, for example, if you look at the cases where there is a cross transcript in the same word, we mapped everything into one language. We build an FST for this one as well. We look at also at the phonetics, and phonetics was kind of, maybe we should not look really at the word sequence or the character sequence. Maybe we should look at the sound of what's happening. And of course, this is back off from what people have been doing in the ASR. Now we're back to the word already, because we need to make sure that we have some output that we trust. But remember, across different languages, a kind of, if the ASR could use a kind of with a wow, fa, and the reference is a kind of, well, that's not very bad, is it? Because a kind of, it's not an Arabic word, but a weekend is an Arabic word. Me and Murad maybe agree on this, because we say have a nice weekend all the time, or ma salama, weekend sa'id, whatever, right? But we don't say a kind of, but especially we have seen this in the word pieces and the end-to-end, the model is learning acoustics and semantics and language model together. They don't have a really higher control on what the machine is producing. So you don't want to really penalize the machine that has given you a kind of, or artificial sensors. But also it's not very good, because artificial here, when you have art in Arabic and official in English and sun is in Arabic, sensors in English, you don't want to do that. So this is a kind of the challenges. And we look at the phoneme similarity distance. So these are the matrices we have looked at. We also finally looked at semantics. So we said, you know what? Let us have a black box. It doesn't matter. You will have the output in Arabic. You will have the output in English. You will have partially output, partially English. Let us map everything to Japanese. Japanese as an extreme example. And we're not really Japanese. The example is Japanese. We're going to use Google Translate or, again, translation engine that supports multiple language. We map everything to Japanese, and we measure the cosine similarity. And actually, it was not crazy. We managed to get some everything. And this is what we managed to do across different ways of evaluating the concept. At this stage, we have not yet proposed a new evaluation method, but we increase the awareness and we show the limitation and the challenge in each one of them. So we apply different systems, and we see our evaluation metric, the correlation is reasonable. So here is our method says, what, system 1 is the worst, system 3 is the best, and we see the different evaluation methods correlate with the findings across all of them. So the word error rate, the character rate, not adequate for evaluating multilingual code switching. Transliteration does not consider pronunciation similarity. Of course, we understand this when we see a kind of. Phonetic similarity is good, but it falls short when there is a limit. There is a mixed transcript within the same word. The effectiveness of semantics is good, but limited by code switching, the machine translation performance of code. But actually, it's not crazy. And so, what we are looking at is a complementary way to add this together into one solid way that we can use to produce reliably. That's it at this stage. The future work is that we are looking at building a leading board and a corpus, benchmarking corpus for multi-general code switching, and hopefully we will do it sometime next month, but maybe it will be delayed. So I have 5 minutes in the time. Maybe we can move it.